Hi, it's Jan Beta, and today I'm going to do something slightly unusual for this channel. I'm going to attempt to build a Hi-Fi amplifier. Well, not quite the highest of Phis, but yeah, you're going to see. Yeah, the mission is to build something that doesn't necessarily have to be very loud, but it has to be very efficient. So I'm using these little, literally stamp-sized circuit boards that have the PAM8403 chips on them. These are the little ICs in the middle there. These are very plug-and-play digital Class D amplifiers that have 3 watts per channel. These are the stereo versions. I think there's also mono versions of these, and higher power output and higher voltage input versions. I have these. They are like $1 each or something like that, or even cheaper, depending on where you get them. You can search the usual platforms for PAM8403 and you're going to find these. I've used these before to build things like mobile speaker from parts I salvaged from trash. Like when you have speakers and only have one speaker left, like a pair of stereo speakers and only have one speaker left, you can use these to make it a USB powered little amplified speaker. That's what I did a couple of times already. I think these are really handy for all kinds of projects because they just require a 5-volt input, and basically you input an audio source and get a 3 watts per channel output signal into 4 ohms, I think, and into 8 ohms. So these work with speakers from 4 to 8 ohms without any problems. Obviously, you can also get these ICs by themselves, which is even cheaper, I believe. But you don't have to, because these little circuit boards have a lot of the recommended surrounding components all on there already. It is also recommended to use a larger filter capacitor on the voltage input to make up for any inconsistencies of the power source. I'm going to use a USB power bank as a power source for my build here, so that's going to be pretty consistent. I'm still going to add quite a large capacitor there. Let me take a second to thank PCB for sponsoring this video and many of my other videos. They are celebrating their 6th anniversary at the moment, so there's a lot of things going on with PCB. So PCB have their 6th anniversary celebration and their mid-year big sale going on at the moment. So you can win all kinds of prizes, including coupons and PCB gift bags with some of the goodies you can see here. I'm going to link to it in the description. Yeah, I'm basically making this up as I go, and I'm going to build this from parts that I have in my collection here, lying around, basically scrap. I think I'm going to use a little circuit board to put these on. And I'm also going to use this enclosure, which is, I don't know how many hundreds of times this would fit in there. I'm using this larger enclosure because maybe I will add more functionality to this later. So I'm just going to go with this. And I have it lying around. Just a standard plastic enclosure that I'm going to use for this build. This is going to have a little volume pot. This has on-off switch. I'm probably going to use one of these USB inputs for the power. It's going to have like a little audio jack, and it's also going to have RCA plugs as an input. For the speaker terminals, I was considering using this salvaged part from a Hi-Fi thing. I don't even remember which model this came from, but it was one that was very beyond repair. It was all blown up inside, so I salvaged a lot of parts from that. I don't think I'm going to use this. I'm going to use these terminals, which have 4mm banana plug inputs, or outputs in this case, and also you can screw them so wire gets clamped in there, which is a standard form of connecting speaker wire. Yeah, I'm just going to use these, I think, for the outputs. yeah, that's the plan. So this is probably going to end up a bit messy like usual with my builds, but I hope I get a functional little amplifier out of this. I haven't decided yet if I want to put an internal like power bank in here, which would of course be an option, which would be pretty nice. So you only have to this for charging it from the outside. I think for now I'm just going to go with an external power source and yeah, have this be powered from externally. But the case is large enough so you could put a power bank in there. Okay, let me sketch out the plan basically. So we have two of these little PAM things that we are going to use one channel each. So this is going to be left out, and this is going to be right out. A volume pot that is going to be connected here. We're going to have a power source where this is going to be connected in parallel. I also want a switch. And I think I might want to add an LED. And then basically we have our inputs. And we have a capacitor here. Yeah, that's basically all there is to it. We need an input, a potentiometer, which I have, like a stereo potentiometer, which is just two potentiometers basically connected, mechanically connected, not electrically connected. This is like a volume potentiometer. You want to go with the logarithmic, I think this is a 47K. Yeah, 47K logarithmic standard for volume potentiometers basically. I think that's about it. I might want to add an LED for indicating that it's on basically. So maybe there's like an LED here or something. Yeah, that's supposed to be an LED. Yeah, so this is basically what we're going to build. We're going to have a power source, which is a USB power bank or a USB charger, something like that. We're going to have a switch. We're going to have an indicator LED that indicates if the whole system is on. Real on-off switch, which basically breaks the connection to the power source. We're going to have a larger capacitor. I think they recommend 417 microfarad one. I'm probably going to go even higher. These are going to be connected in parallel to the power source. Yeah, it's not accurately drawn here. We're going to have our audio input that is going to be connected to a potentiometer, and that goes into one channel of each of these little circuit boards, and then we connect the speaker output terminals. That's basically all there's to it. It's not that difficult to build these things. So I'm going to start by mounting these little circuit boards on a piece of perf board that I'm going to drill holes into on the sides here so I can mount it in the case. And then I'm going to use these little pin headers to connect the connections I need and solder them on so I can do all the wiring on the perf board, which will make things a bit easier. Ha! Perfect. I am going to use these little standoffs to mount it in the case that have an adhesive, like double-sided tape backing with some foamy stuff also, so it's going to be a bit shock absorbent in case this gets thrown around. And they fit the holes, 3mm holes that I did. So the spacing of the pins on these little circuit boards is not as accurate as I'd hoped for, but yeah, it's gonna do, I guess. Okay, doesn't look too bad. Now we want to have the input, the voltage in, hooked up to capacitor for smoothing and like making up for any voltage differences. And we want to have these connected in parallel to our power source. I chose a 680 microfarad capacitor rated at 25 volts. You want to go higher voltage than the actual supply voltage, so yeah, you could go with a 10 volts or 16 volts capacitor without any problems. And you want to go 470 microfarad or higher. That's the capacitor. So and then this is the positive. The long leg on the capacitor is always the positive. We are going from this to the voltage supply for one of the circuit boards and to one of the other ones. Just going to put a wire there. This is ground, that goes to the negatives, and we're going to be fine. Yeah, I told you this is going to get messy, but we don't have any shorts, I just measured. So yeah, got the power supply section of our little PCB done. Now for the input and output sections, I guess we're just going to connect some wires. So I have more or less neatly connected the inputs, the outputs. This is for the power supply. So I did some more or less neat wiring on these. The inputs are wired up, the outputs are wired up. They are not going anywhere yet because we have to do some layout work on the back and front panels, which thankfully in this case, in the case of this case, they just slide out and you can just work on them like so, which we are going to do. Okay, for the front panel we want an on-off switch, power LED, RCA inputs and a phono jack, and we want our volume knob. I'm going to add some masking tape so I can actually mark things, and also great for cleanly drilling into this. Okay, so here's what I came up with. Our back panel is going to have the USB jack for power input. It's going to have these banana sockets for left and right speaker. That's all for the back panel. And our front panel is going to have a little power switch, an LED that is triggered by the power switch. It's going to have our two RCA inputs, our phono input, and it's going to have our volume pot. I put that a bit more left because I thought you would have better access, because the case has kind of a lip. Just quickly measuring the diameter of things. Okay, so the little phono jack is not, it's not deep enough to go through. This is quite like 2 millimeters thick plastic or something. This is made for smaller enclosures, I guess. So it just had to drill the hole a bit bigger, and I'm just going to have to secure it with some glue from the backside. So the left one is white for these. Ah, this is going to be so nice. Okay, that doesn't look too bad so far. Yeah, I like it. And we are going to, there's going to be some like stickers on here and stuff like that, so everybody knows how this is supposed to work. Oh, just realized we actually need 4 connections, obviously, for the speaker terminals. Yeah. So I just decided to have the little USB thing sitting on some perf board too. Yeah, basically so I can secure it, I guess, a bit more. Yeah, I guess I'll drill some holes for these little clamps that this has, and I'm going to solder on the connections on the back there. Just quickly mark where I want to drill the holes. I'm going with a 2 millimeter drill here, actually. Yeah, it actually kind of works. Not too shabby. So let me just determine which of the connections here are positive and negative. So I think this should be the ones. Yep. As for the most important part, the LED, I have something pretty special that I'm not going to disclose yet, because it's ought to be some kind of a surprise. It is pretty special. I'm just going to put some glue here and then have it stick out the front. Looks kind of DIY, which it is, so it makes sense. Yeah, and I am going to glue stuff in place, but not just yet. First I want to test it a bit more and yeah, maybe put it together. Tiny little bit more. So here's our front panel. Noise. Also pretty nice. It's coming together, I guess. Hope it does work in the end. As most of these parts are salvaged from other projects that didn't make it, I'm just going to have to desolder some wiring and stuff. Okay, so we want to go from the power input, which is our USB socket here. Want to go from this pin to the switch, wire up the LED in parallel with a little resistor, and then go to our circuit board and power that. Yeah. And that's going to be, it's all going to be wired in parallel because the voltage stays the same on all components that way. Which is, in this case, a very good idea because we want the full 5 volts. I think these little circuit boards ideally run with 5.5 volts. So 5 volts is kind of a good idea. They run with lower voltage, but they are not going to be as effective, so they're not as loud. I'm just going to go yellow and green for my colors here. Because I can. So yellow is going to be our positive, and green is going to be our negative coming from the power supply. Okay, so we're just going to solder this one on. Here. Quickly testing for shorts. No shorts. Nice. So the negative is going to go directly to our LED. And I think I want to use some heat shrink tubing there. Also want to shorten these legs a bit. I'm leaving the longer one because that's the positive, the anode, a bit longer than the other one, even though I shorted them both now. Which is kind of helpful. So you can still see which polarity the LED should be connected in. So yeah, I'm going to do this. That's going to be quite the stunt, I guess. So I'm going to connect the negatives together on the LED, actually. Because, yeah, the LED should be parallel to the rest of the circuit. So for the other side of the LED we need a similar contraption actually, but with a 100K resistor for protecting the LED from overvoltage and overcurrent. This runs at 3.2 volts. So I'm going to need a 100 ohms resistor for this. You want to be a bit careful with LEDs. They don't like getting too hot, but usually. Quickly soldering something on is completely okay. So the positive should go through the switch. So we are going to connect it here. And then it goes to the LED. And from here it forks to the rest of the circuit. So we're going to need something like this length. And then, well, we're just going from there. So I think we connect this to the middle pin and the other one to the upper pin. So it's going to be on. Actually, let's check that, if that's actually true. Oh, okay, it's the other way around. Ah, glad I checked. So the middle pin is going to be connected directly to our voltage source, and the lower pin is going on to the LED and then to the rest of the circuit. Whew. Probably people are laughing at me who are doing this more frequently. I don't do that much tinkering like this anymore at the moment, so kind of a bit unusual for me, so I don't know. Don't remember much. By the way, if you like these kinds of tinkering videos too, let me know in the comments. Maybe I'll do more of this stuff. So we are going to join this and this. And this goes into the LED thing. And we want some heat shrink tubing. Ow! Okay, that's pretty hot. But alas, it worked. That's something. So at this point we should have a functional on-off switch and a functional LED. Okay. Okay, turning this on. It seems to work. Let's see. Yay! And as you can see, this is a so-called disco LED. Yeah, and here's what it does. It's just discoing away. That's nice. And now we should have 5 volts still on the output of our voltage rail. Let's check that. Yay! 5.1. Nice. Okay, so this should, in theory, just be a matter of hooking up the right things to the right things now. And yeah, we have to hook up the input, of course. Okay, so we have to connect these feet to our PCB here, I guess. Okay. Actually doesn't look too bad. Yeah, actually our outputs are these here, so we want these. Yeah, maybe something like this. I'm just going to glue it in place, you know. These are like adhesive strips on the back with a bit of foam, so can make up for any inconsistencies. I'm probably going to go in and add some epoxy or something to that when I mix some. Wow, okay, that's not going anywhere. Nice, okay. That gives a nice positive connection here. That's pretty cool, actually. Okay. So we are going to have to connect our wires from previously, the black and the red one, with the green and the yellow one, which we don't need a lot of green and yellow ones. I'm adding a tiny bit of flux to have it make it easier. for the solder. Okay, now we should be connecting the other stuff. I'm connecting the outputs first because that's easier. Yeah, basically there's just the white wire goes to the black connector. Actually, I put it, I wanted to put this upside down, but yeah, that's how it is. So the white wire goes to the black connector and the red wire goes to the red connector, basically. So now for the inputs, we want to connect the white ones to ground. Yeah, which is basically just ground. We want to connect them here, for example. We're going to connect all the grounds together at one point. We need some ground cabling here. We need a ground here on the potentiometer. We need grounds here. And we need a ground here. And then this all should connect to this one here. I'm just going to cut this here. We're going to make one nice ground plug. Okay, the last step before we actually test this is going to be connecting the inputs of the circuit board to the two potentiometers that these are, like so, or maybe the inner ones. Basically, you have one ground connection and you connect to the two other pins, the input and the thing that it goes into for a volume potentiometer. The resistance here is changing from basically 0 resistance to 47 kilo ohms in this case, by turning the knob here and turning it all the way clockwise. In this case has the lowest resistance, and turning it counterclockwise yeah, makes the input more silent, so the volume is lower. The resistance gets higher. And if you use the other side as your grounding pin, basically the potentiometer works the other way around. So you would have higher resistance turning it counterclockwise. Lower resistance, sorry. It is a bit confusing, but basically these are just two potentiometers changing the resistance of the input signal that finally reaches our amplifier boards. And it doesn't matter which one is left and which one is right. We just have to connect the inputs accordingly. And the inputs are going to be connected. This, our little phono jack actually has color-coded little flaps here. The big one is always the ground, and then you have two for the two signal lines. We're going to connect the red one to the red one and the white one to the white one, or the silver one. And we are going to connect those to the white one is going to be the one that's connected to board on the left, which is this one, and the red one is going to be connected to the little potentiometer that goes to the board for the right channel, which is this one. So yeah, I'm going to connect these together because you can use this as kind of a daisy chain out as well, because it's just parallel with the inputs. Yeah, that kind of makes sense for connecting more speakers or something like that. Okay, so this should actually be it. All the cables are in. Should glue some stuff in place, especially the USB jack here and the LED. But for now, I think we're ready to test this and connect some speakers. Okay, got my test speakers hooked up. And yes, they are actually another pair of JBL Control ones that I got for really reasonable money recently, because the ones I did the refoaming on recently in another video ended up as my kitchen stereo, as you've seen in the video. They are still there and still serving me well. These are my new test speakers now. They are pretty beaten up, where I think they are working. And they are between 4 and 8 ohms, which is perfect for this amplifier. Hopefully, if it works. So without further ado, let's just try if we get anything out of this. So I actually had to look for a working cable to connect my phone to it. And I have to look up some soundtrack. Let's turn it on. Let's just put this plug in here. So there we go. Oh, we have a high frequency whine. Let's see if we get any output at all. Yay! And it's loud, it's quite loud actually, that's nice. Wow, okay, so it works. Only thing is we get some high frequency whine. Let me see if I can... Don't know if you can hear it through the microphone, but it's there. So I'm going to turn it off for now. I think the issue here is simply that I used unshielded cables for these long connections here. There's basically, these cables act as an antenna and just pick up all the noise around them. And because this is the low energy side, the signals are going to be amplified, and yeah, for the other side it's not that important to use shielded cables. It doesn't matter because the signal is so high power that any noise is not necessarily an issue. On this side, the noise, all the noise gets amplified, and with my little cabling stunt here, I left a lot of antenna area, so to say. So I'm going to try to replace these, at least the longest cables here, with a shielded cable. I also added these little capacitors on the 5 volts rail closer to where the voltage is actually needed, which helped a bit actually, so I'm going to leave these in. These are 100 nanofarad capacitors, just soldered in from plus to minus on the circuit board here, just the positive voltage supply to ground. So they clean up the voltage even more, which is a good thing. Yeah, so I absolutely got the noise down to a level that I can live with. It is like grounding issues. I recabled some of the groundings. I grounded the shell of the potentiometer, and now it's a lot less apparent. And the thing is loud. It's amazing. Yeah, I guess now that this is working, as it should, I'm going to apply some epoxy to the LED, the little phono jack, and the USB socket so that they are kept in place. Okay, now it's a matter of waiting a couple of minutes. This supposedly cures in 5 minutes, but I'm going to give it a couple of minutes more. I was just about to close this, and it turns out they actually supplied 2 top halves or 2 bottom halves, top halves probably. There are no screw holes. It was supplied with these long screws that are supposed to screw in from a bottom hole into these posts, I suppose. But it has these posts on both sides, as you can probably see here. I don't know if you can see it, but it has these posts. So I'm just clipping the posts on the lower part here and drill a little hole to hopefully screw some screws in, because it also comes with these rubber feet, which is rather nice actually. But unless I'm doing something terribly wrong, which I don't think in this case at least, yeah, they supplied the wrong parts, which was probably why this was so incredibly cheap, if I remember correctly. Had this sitting here for a while, didn't use it, as I said. But yeah, I think I'm just going to screw the screws in from here to penetrate the case, and then screw them in again from the other side to actually close it. And I'm using my new toy, which I got for my birthday recently, and yeah, I kind of love this thing actually. Basically, the modern version of this Dymo. Okay, there we go. We have a little disco indicator, and yeah, I think this should be pretty self-explanatory. We have the 5-volt USB in, stated that it's 5 volts, so nobody messes that up. Speakers you can connect are 4 to 8 ohms, as we've seen for these little PCBs. Yeah, that's it. I'm pretty satisfied with how this turned out, and it's really loud too. That's pretty nice. Yeah, I think I'm pretty satisfied with how this turned out. It's really lightweight and it's going to live in the garden. My bicycle club rents, actually. That's what I built it for. So we need something that can work off-grid with like a USB power bank for hours and hours. And this is going to do that. You can connect normal speakers 4 to 8 ohms, obviously. Yeah, this was something a bit different. Let me know how you liked that, if you liked that at all. Just as an inspiration, what you can do with these little circuit boards. There's, as I said, there's different versions of these. There are versions that are a lot louder for 12-volt power supplies and things like that. Yeah, it's basically just to let you know that these things exist and are really easy to work with and really fun to play with and useful for a lot of use cases. Yeah, I'm definitely going to add a knob. That hasn't arrived yet. I've ordered one, but yeah, I'm probably going to post pictures of this somewhere. Thank you so much for watching. Thanks for subscribing to my channel. Thanks for supporting my work on Patreon or on the YouTube channel memberships thingy or elsewhere with your donations and your love. So yeah, thank you very much. I'm Jan Beta. Thanks for watching. See you next time. Bye.